Hi everyone, welcome to my channel, continuing the series SNCF 317. Today we are going to explain the malware and file policy. Like any firewall all over the world, it has an antivirus engine inside it, built-in antivirus, like how you have an antivirus in your endpoint. Uh, this is the same. There is an engine, a powerful engine, of course, inside the firewall that's doing antivirus activities. Now, the situation is a little bit different with firepower and FMC, that it's not a normal antivirus, it's a malware protection actually, and malware defense. So, malware could be antivirus, could be ransomware, could be Trojan, could be anything related under the category of malware. So how this work actually, the firepower or FMC is connected directly with Cisco Talos, as we know over the internet. Now, Cisco Talos have something called AMP. AMP with Cisco Talos has several pictures. Like you can apply AMP on the firepower, you can apply AMP on the endpoint device as Kaspersky, McAfee, Norton, anything. They can apply AMP also in email security appliance, web security appliance. So AMP actually can be applied, like Cisco made it dynamic, that yes, I want to let the AMP to play the role in antivirus in the firewall itself. Yes. Why do I need for that? Because I'm connecting to the internet 24/7, and all my employees are going surfing the internet, downloading some stuff. So yes, and I need here a malware protection. So why they concatenated with the file policy or files? Actually, like any antivirus and malware can get to you in a file format. This file could be any format, could be a PDF, could be an exe file. So it should be like a file should be protected. Now, when we are talking about file could be like a PDF executable file, could be image, could be anything. Then yes, I might need to block a certain file by its type. Like I don't want the executable files to be installed, so I block it. Here I don't need for any inspection, I need any protection for that. It has this type, I need to block it, that's it. It will be blocked. The same of PDF, the same like of Excel format. Any Excel format, block it. So it will be blocked. It will not be inspected, it will not be scanned to be protected against that. But when I'm talking about like malware scanning and the protection, yes, this need for inspection and this need many things. And please remind my talk all over the time. Whenever you are working with next generation firewall features like IPS, IPS, application control, web application filter, malware, everything, please try to enable the SSS decryption policy that I explained before. Because if you are doing that, if you are downloading a file from an HTTPS as secured and there is no SSL decryption, so the malware will be hardly to understand it. So please always make sure that your SSL decryption is enabled. Well, let's go to know what's AMP. Actually, AMP is an intelligence-powered integrated enterprise class advanced malware analysis and protection solution. This AMP can do three main functions before an attack, during an attack, and after an attack. Before an attack, using something called global threat intelligence. This is also from Cisco Talos. Everything is from Cisco Talos. Okay, the team is working 24/7 for you guys. So pay for the license to get better result for that. And they have, of course, research as a group, and these feeds has a strength of defense to protect against known and emerging threats. Concentrate. Known. Known what? It's working with a signature. Okay, a huge database has in billions signatures that's comparing with it. And this team working day and night 24/7 just to update the signature. Then during the attack was doing, it's used the intelligence coupled with known file signatures and Cisco Threat Grids dynamic malware analysis technology to identify and block the policy violation file types. After an attack or after the file is initially inspected, the solution goes beyond point time detection capabilities and continuously monitors and analyzes the file activity and traffic. Great. So let's understand how FMC is working with FTD and all these criteria. If I go to our diagram here, our topology, sorry, and I said pen. Okay. Now, we have our FMC is residing down, you know it now. This is the FMC. And our firepower here, the firewall. Now, actually the firepower, FTD, is not connected to the app. It's not communicating with the app. There is one condition that will communicate with it, but mostly who's communicating? The ones communicating is the FMC. So FMC here, it will go, it's connected to the internet, of course. So it will go, and here you will find Cisco Talos and inside it AMP. Okay, I don't like this color. Let's make it black. Black is good. Okay. So suppose that a file came to firepower, to the FTD. Came from anywhere, maybe from the internet. This PC in VLAN 10, go to the internet, download a file. So download a file means it's coming here. Or could be between inter VLAN routing. VLAN 10 is sending a file to VLAN 20. Okay, so it is here inter VLAN routing, so it has to go to the firewall and go. So the file received, sent to, presented to the FTD. Then what FTD is doing actually, it builds the file and calculate the hash value. The hash value is SHA 256. Great. After building the file and calculate the hash value, FTD will send the calculated hash value to FMC. So it will send the calculated hash file value to the FMC. FMC automatically what's doing is it checking inside the cache. Okay, this hash I have it before. If I have it before, I will reply directly and no need to communicate with AMP. If it's not hashed here and I don't know anything about it, so FMC will send this to AMP Cloud. Okay, AMP Cloud will take this hash and do its analysis and send the disposition, retain the disposition for FMC. Okay, this is the result. This is a virus, this is ransomware, or this is beyond safe file. Okay, it will send the result. When sending the result to the FMC, FMC will cache the results here, and after that will send the disposition to the firepower, and firepower will take an action based on the policy it has. This is the procedure actually. So FMC directly with AMP Cloud. And this is checking the AMP is working with hash SHA-256. Keep it in your mind. It's working only with SHA-256. Call it SHA. SHA. I hate this word, SHA. So SHA-256. Great. So going back to our okay, delete here. Thank you. I finished. Delete. Up. So now, yes, this malicious software is intended to damage or disable computer, blah blah blah. Yes, we talk about it, and we talk about like AMP had several capabilities for firepower. File control, we talk about it. Now, advanced malware protection. File analysis, yes, AMP uses the cloud intelligence to block and or alert on known malicious software before it reaches the endpoint target using these techniques. SHA-256 hashes. And actually, this is the process that I explained in our diagram, in our topology. Great. Types of malware cloud lookup. There is a static file fingerprint called Spiro. What is Spiro actually? Spiro is not working with hashing. It's not calculating the SHA. What Spiro is doing? First of all, you have to know that Spiro is working only with executable file related to Microsoft. Why they did it like that? Because believe me, in all companies and offices, 90%, if not more, they are using Windows, either Windows 7, 10, 8, Windows Server. So Windows actually, anyone is familiar with it, and all the program is executable program working on it. So Spiro working for executable program regarding Microsoft. Great. So how Spiro is working? Spiro is working on the attributes. It's collecting like attributes and generates signature based on these behaviors. So I have a file. I can generate attributes from this file. I can collect attributes and generate signature of this value. Spiro, what they are doing is including the header information and DLL files on the static metadata information. Great. The Spiro signature is analyzed and the Cisco Cloud arrived at the malware score. Okay, so when it's sent to this Spiro finished the signature and send the signature to FMC. FMC sent it to the AMP Cloud. AMP Cloud did its inspection and analysis, and it scored it as a malware. This score is returned to the FMC, which forwards it to the device. What is the device? The FTD. And FTD will say to FMC will return that, disposition that to the firepower, saying, hey, this is a malware. Okay, so if this score is high, the file could be marked or convicted as a malware. This is all about Spiro. So it's like that, guys. Normally, how would the chronological order for that? First of all, there is a clean list. Clean list is like white list. I will tell you that you as administrator put it in a custom detection list or a clean list. Okay, that this file is beyond. This file is clean, intake, safe. So the FMC will look to this list first. If did not find anything, it will do a communication with the FMC. It will send it to FMC. FMC it checks for the hash. Does not have the hash. It will send it to the AMP Cloud. AMP Cloud will do the analysis and will send it back to the FMC, and FMC will disposition this to the firepower, and firepower will take an action. The process that I explained on the topology. If there is nothing there, couldn't find is unknown. So there are another factors how the file can be inspected. Spiro one of them, and I told you it's working with executable file. Local malware analysis, actually you can imagine that this is an antivirus, a software made by Cisco Talos team and called CLAM AV or Claim AV. Like any antivirus, but it's installed inside your FMC. It will do the it checks inspection locally. Great. So here was saying the device inspecting a file using a local malware inspection engine known as Claim AV. It's an open source antivirus and anti-malware. So it's not only antivirus, it's also anti-malware. Toolkit maintained by Cisco. Great. Local malware analysis can generate a malware hit and block the file if it's suspected to be a malware. Great. If I just quickly go to Firefox, Firefox, what is it? What's going? Firefox. No problem. Chrome. If I said Talos Intelligence, I want to open. Okay. Here in the where it was software, if you open the software, here you find the Snort engine, where Clam AV. You see, open source antivirus engine for detecting Trojan viruses, malware, and other malicious threats. So this is also Talos working with. It has like many engines for that. So when you see this one, it means a Snort. When you see this icon, I don't know, Talos team has something strange. Okay, so it means Clam AV. They don't change their icons. This is more flows. They have a lot of software. Anyway, let's go back here. So this is the local malware analysis. So there is also something called dynamic analysis. The dynamic analysis simply, it will send the file. If this file is unknown and no one has any clue about it, then if you enable this feature, then you will send the file itself, for example, to the AMP cloud or to the sandboxing. If you did like a sandbox virtual environment, there it will be analyzed and to check the behavior of this file. They will run this file and start analyzing this behavior. It's telling you that this is between 7 to 10 minutes or more, and I'm sure it will be more, to return a disposition, to tell you what is the status of this file. Then what they are tracking several things. If this, when I executed this file and this file is running, it is try to make IPS aviation or firewall aviation or operating system protection. Is it making data obfuscation, something related to remote access? It's a start to check the behavior of this file and do the analysis. If the analysis score is high, the file will be convicted as a malware. Simple. By this time, the file has already passed through the device, so clearly it can be blocked, okay, because the hash is now classified as a malware after doing analysis. So it's a now malware, so the hash will be updated from the AMP cloud to the FMC. Any further detection of this file will be immediately return a malware disposition. Great. If you enable dynamic analysis in your file policy, file will be uploaded directly from the appliance or FTD device to the cloud. This is the way that how firepower is connected directly to the AMP, because when you want to send the file automatically, they do not want to bother the FMC to do that. So FTD will do it directly with that. Great. Retrospective events. I like this feature. You know, there are several lines here. I will tell you what is this exactly. Consider you have a file. This file, right, let me go to the topology. Great here. So suppose that, let me take the pencil, okay. Suppose that VLAN 10, this is the PC, has a Word file, for example. I worked on this Word file, I did some reports and tables, if you want, and I stored on a server. Great. Then the AMP is checking and it say this file is clean and no any problem with that. After that, the guy in the PC VLAN 20 took this file and did some modification on this Word file and save it and send it, for example, to someone else. Then still AMP is checking, and yes, and it's remarked that this file is intake and file. So suppose that I change it, and in a sequence, or like by luck, by coincidence, that when I'm sending this file is infected, and I send it to PC VLAN 10. Does not really mean VLAN 10, maybe this PC, maybe anyone. So the AMP file actually discovered that this file is got infected. So you will find in the history that, oh, this file created by VLAN, PC in VLAN 10, it was intake. After that, it's stored in server. It was intake, and it took a backup, and it was intake. After that, PC in VLAN 10 took it and worked on it, and it was intake. When this PC took it, it was intake. When this PC sent it to the PC to VLAN 10, this file became infected. It has something, so it can be stopped, and it will mark it in the log that yeah, this is a malware, or this is a virus, or whatever you want. Okay, so if you want to read about it, okay, we can read it now. Thank you. Okay. So occurs when the malware disposition for previously detected file changes unknown malicious, unknown يعني, it's unknown malicious or it's intake, it's fine. When this happens, it's pretty much always refers to a file that was previously assigned the disposition unknown has been since discovered to be malicious. Great. A retrospective event can occur minutes or even days after a file was first detected, and the change will be reported to the FMC from the Cisco Security Intelligence Cloud. Yes, the process that I explained to you could be like days, could be weeks. It's fine. It depends until it's infected. Then the FMC will then update all the previous detection events for this SHA-256 value with the new disposition, because the AMP tell the FMC, oh, you have a file, this file got infected. So FMC automatically will update its cache by its SHA. Okay, great. Even if a new piece of malware escapes detection at first, once its true nature has been revealed as a malicious, you will be altered so that you can go back and find out exactly where it traversed your network and block it on all your firewall devices. It could be passed, and when I receive it, like, yes, I got infected, but most probably the AMP will detect it. To make sure, like most probably the majority of the time, the AMP will be detected. Great. So, not this. Okay. So file dispositions, we have several type of file dispositions. We have a clean. This is a clean that the file is benign. This update came from AMP Cloud, or you manually enter that in the clean list or the custom detection list. So it's a clean. Unknown, the file has not been seen anywhere yet, or sandbox score was not high enough to convict it. Great. So the status is unknown. I couldn't understand it, so it's unknown. Malware, the file has been categorized as a malware either by the cloud or by local malware analysis, either by like advanced malware protection, the app cloud, or the local using the CLAM AV, or it exceeded the malware score threshold in the file policy. Great. Unavailable, this disposition is not actually returned from Cisco. It means something prevented the cloud lookup. Okay, this actually is not received by the AMP cloud. It's blocked somewhere or prevented to do the lookup for that. Custom detection, the user has added the file to the custom detection list. The user, it means you as a network engineer. Archive files, we have a problem actually with archiving. When you archive file, then you need your antivirus generally to look inside the archive file to have the ability to detect what's inside it, to inspect what's inside it. It's like doing a DPI, deep packet inspection, if you want, something like that. So the archiving, we have three levels of archive: one, two, three. So if you like zip the folder once or two or three, but the first one, the system will not consider it as a one. So for example, if you have a zip folder and you did zip again, so no, this will be considered as a one zip. If you do it again, now this is second zip. If you did it again, so it means third zip. So only the maximum three zips or can the AMP have the ability to inspect inside it. And this need actually to be enabled. File disposable caching. Great. The disposition caching. Once a file the disposition is returned from the cloud, it's cached. Okay, we have several things we explained it. Clean. A clean will be cached for hours. After 4 hours, of course, it will be deleted. Unknown 1 hour, malware 1 hour, unavailable, not cached. It's not important for the FMC. Custom detection, this disposition never results in cloud communication since the FMC maintain the custom detection list locally. Exactly, because if you have this file in your custom detection list, then there is no any communication with your FMC and AMP cloud. So just it will look inside it, and so the file in the custom list. So you need to cache it actually. It's there. Cloud communication. Okay, great. Then the communication between the FMC and the AMP cloud is on port 443. If you want to change it, you can change it for a legacy port like this, but it's not recommended. Make it 443. I believe for the theory part, we are pretty good for this time. I don't want to make it longer. So I hope you like it and it was informative for you. So please wait for me for the next video to make a lab, how AMP is working and how we can detect files. So please wait for me there, and do not forget to subscribe, like, and share. See you next soon.